In this video, I'm going to cover questions 11 through 20 of the 1997 Grade 9 Pascal Math Contest. 12 balloons are arranged in a circle as shown, counting clockwise. Every third balloon is popped. C is the first one popped. This continues around the circle until 2 unpopped balloons remain. The last 2 remaining balloons are. So what are they doing in this question? They're starting here with C, it's the first one, and they're going clockwise, so in that direction, and they're popping every third balloon. So this is the first one that's popped, and let's just keep going here. This would be number 2, 3, 4. So this is the third balloon. Every third balloon they're popping. So let's just keep that going. 1, 2, 3. I would be next. 1, 2, 3. L would be next. Now, A, B, but be careful because C's already popped. So the next one in line would be D. And then continuing in the same fashion, E, G, H is the next one to be popped. Then J, K, A. Then B, E, G. And then J, K, B. And then finally E, J, K. And when the process is complete and you have only 2 left, the only ones left are E and J. So therefore the answer is D. The graph shows the number of students who selected each of 5 possible choices in responding to a question. The correct response was the most frequently one chose. The percentage of students who selected the correct response was. So they're telling you that the most frequently chosen response is the correct one. So it's this one, obviously. So if you look at this graph, it's approximately 1100. So the percentage would be 1100 over the total. So what's the total? A is about 300. B is 1100. C looks like 100. D is 600. And E is 400. So this is 1100 over 2500. And this becomes 11 over 25. And if you multiply top and bottom by 4, you get 44 over 100, which is exactly 44%. So the answer to this question is E. Janet has 10 coins consisting of nickels, dimes, and quarters. 7 of the coins are either dimes or quarters, and 8 of the coins are either dimes or nickels. How many dimes does Janet have? Well, for those of you watching outside of Canada, just a quick lesson. A nickel in Canada is basically 5 cents. That's the currency. A dime is a term used to describe a 10-cent coin, and a quarter is the term used to describe a coin that is worth 25 cents. They've told you in this question that she has 10 coins. So her N nickels plus her D dimes plus her Q quarters equals 10. And then they also tell you that 7 are either dimes or quarters. So that can also be written in an equation. D plus Q is 7. And finally, they tell you that 8 is how many dimes and nickels. So that means that dimes plus nickels is 8. Now what we can do is we can just plug this into here. So N plus D plus Q is 10, but we know that D plus Q is 7, so we can put that here as 7. So that becomes N plus 7 is equal to 10. And solving, we get N equal to 3. So now we just put N equals 3 back into there, and we get D plus 3 is equal to 8, and therefore D is equal to 5. And that's what the question was asking, I believe. How many dimes does she have? So dimes is equal to 5, so the answer here is D. In the game Try Square, 3 points are awarded for each triangle found, and 4 points for each square. the highest number of points that can be achieved for the given diagram is. Okay, first let's figure out how many triangles can we find. Looks like there's one there, one here, and one here. And then of course, those are the small ones. And then the big ones would be this big one here and this big one there. So that essentially means 6 triangles. And for each triangle, there's 4 points for each square and 3 points for each triangle. So we got 3 points here. So that's a total of 18 points that we got for the triangles. Now let's figure out how many squares. Well, it looks like there's 4 of these small ones, like that, and then one big one all the way around. So that's a total of 5 squares. And for each square, they're giving you 4 points. So that's 20 points. So the total in this case is 18 plus 20, which is 38 points. So the answer here would be A. Each of the numbers 1, 2, 3, and 4 is substituted in some order for P, Q, R, and S. The greatest possible value of P to the Q plus R to the S is P to the Q plus R to the S. What's the greatest possible value of this? This is just, I think, trial and error. Just plug in some numbers and see what you get. So we want the greatest, so I'm going to go with the greatest number, which is 4. And I use the next greatest number, which is 3, as the exponent. And I'm left with just 2 and 1 for the remaining letters. So if I do this, what do I get? 4 to the power of 3, I believe, is 64. Plus 2, and that is 66, which is one of the answers. But is that the greatest? Well, let's see if we can find anything greater. Now let's choose 3 for P, and then I'll choose 4 for the exponent. And then, of course, we still have just 2 and 1 as the remaining choices. 3 to the power of 4 is 9 times 9, which is 81, plus 2, and this is 83. So when you manipulate the numbers in a different way, you got a bigger answer. So this is indeed the correct answer, 83, because there's no way of getting 162. In the diagram, all triangles are equilateral. What fraction of triangle ABC is colored black? Okay. First of all, count the number of colored triangles, and if you do, you'll find that there's 27 of them. And what we essentially have to do is figure out what is the fraction 27 triangles over the total area of the biggest triangle, this whole thing. And if we do that, we will get what they are asking for. So what I'm going to do is just label the triangles as having a base of 1, length of 1, like that. Just make the math easy. And since they're equilateral, these sides are also equal to 1, like that. So essentially it's 8 by 8. And what I'll do is I'll draw another triangle here to make it less confusing. So this triangle that I drew here essentially represents the big triangle. And I want to find its area. So draw a perpendicular and call that height. And we know that from here to here is 4, right? You can confirm that by looking at the triangle up there. And then the hypotenuse over here is 8. And this is, of course, a right triangle. So using Pythagorean theorem, we know that h squared plus 4 squared is equal to 8 squared. So h squared is equal to 64 minus 16. H squared is equal to 48. And therefore h is equal to the root of 48. Now we can figure out the area of this triangle. It's essentially 1/2 times base times height. That's the formula for area of a triangle. The base is 8, and the height is the square root of 48. So this essentially becomes 4 times the square root of 48. So we've got this part here, the total area. Now we need to figure out the area of those tiny black triangles. So let's draw one of those black triangles. And we know that the bottom has a length of 1, this whole thing. So therefore, this would be 0.5, and this would be 1. And very similar to what we did previously up here, we're going to find its height. So we have 8 squared plus 1/2 squared is equal to 1. 8 squared is equal to 1 minus 1/4. 8 squared is equal to 3/4. H is equal to the square root of 3 over 2. And therefore the area of one of these small triangles is 1/2 base times height. The base is 1 here. The height we just figured out as root 3 over 2. And therefore the area of each of these small triangles is root 3 over 4. So finally, we can figure out what they're asking for, which is the ratio of all the black triangles, which is 27 of them, all over the total. Well, each of the small black triangles was root 3 over 4, and the total area, if you recall, up here, was 4 root 48. Like that. And this will give us the answer to the question. We just have to simplify it. So we got 27 root 3 over 4. The bottom will become essentially 16 times 3, all under the square root sign. This is 27 root 3 over 4. This is 4 times 4 root 3. And then we have 27 root 3 over 4. If we invert and multiply, we get 16 root 3. And the good news is that the root 3's cancel. So we just get 27 over 64. Now let's see if 27 over 64 is one of the answers. It is. Choice E. The digits 1, 2, 3, and 4 can be arranged to form 24 different 4-digit numbers. If these 24 numbers are then listed from smallest to largest, in what position is 3, 1, 4, 2? Well, you have 24 numbers, and 6 of them will begin with a 1. It'll be of that form, like that. Then the next 6 will begin with the number 2. They'll be like this, 2 followed by 3 numbers. And then the next 6 will begin with 3. And similarly, the last 6 will begin with the 4. Now we are not interested in the first 12. We only are interested in the numbers that begin with the number 3, because 3, 1, 4, 2 is what they've asked us. So let's write down the numbers that begin with the 3. We got 3, 1, 2, 4, 3, 1, 4, 2, 3, 2, 1, 4, 3, 2, 4, 1, 3, 4, 1, 2, and 3, 4, 2, 1. Now, are these in order from smallest to largest? And I believe they are. Yes, they are. So that helps. So this is essentially the 13th number in our list, because remember, these were the first 6, these were the next 6, so this is the 13th. And this number, which is the number that they've asked us about, is therefore going to be the 14th number. So the answer here is B. 20 to the power of 50 and 50 to the power of 20 is written as an integer in an expanded form, the product of those two numbers. The number of zeros at the end of the resulting integer is. Okay, well, let's see what we get here. You got this big number multiplied by 50 to the 20. Okay, I believe the key here is to get as many tens as possible, and that will give you an indication of the number of zeros. So we're going to have to break this up. 20 is broken up into 2 times 10, and 5 is broken up into 5 times 10, like that. And then this can be written like that for 2 to the power of 50, and then 5 to the power of 20. And then the tens are 10 to the power of 50 and 10 to the power of 20. I'll write them on the other side. And these tens, of course, will combine to become 10 to the power of 70. And therefore, we have 2 to the power of 50 and 5 to the power of 20. Now, can we further get more tens? I believe we can, because this can be broken up into 2 to the power of 30 and 2 to the power of 20. And that will match this one, which is 5 to the power of 20. And we have 10 to the power of 70. Now, because these have the same exponents, we can combine them. 2 times 5, which is 10 to the power of 20. 10 to the power of 70, and finally 2 to the power of 30. So what this does is essentially allows us to see that this whole number is essentially just 2 to the power of 30 times 10 to the power of 90. 2 to the power of 30 is some big long number. And in case you're wondering what it is, it's this number right here. And then what 10 to the power of 90 does is it just adds a whole bunch of zeros. Like that. How many zeros does it add? 90. 90 zeros. So that's what the question is asking, that when you write this number out, how many zeros are at the end? And of course the answer is 90. So the answer here is C. Three balls, number 1, 2, and 3, are placed in a bag. A ball is drawn from the bag and the number is recorded. The ball is returned to the bag. After this has been done 3 times, what is the probability that the sum of the 3 recorded numbers is less than 8? So what are they asking for in this question? You've got 3 balls and they have the numbers 1, 2, and 3 on them. You choose a ball and then you put it back. Then you choose another ball, you put it back, and then you choose another ball. And they're saying when you have these 3 balls, the sum, we want it to be less than 8. So in this case, if I chose the ball with the 1 3 times, the sum would be 3. So we can very quickly figure out all the possibilities. There's going to be 3 times 3 times 3, which is a total of 27 total possibilities. There's going to be 9 that start with 1 as your first ball, like this. 1, 2, 2, 1, 2, 3, 1, 3, 1, 1, 3, 2, and 1, 3, 3. And we can add up the sums. 4, 5, 4, 5, 6, 5, 6, and 7. And similarly, we're going to have 9 numbers, or possibilities rather, that have 2 as the first ball. 2, 1, 1, 2, 1, 2, 2, 1, 3, 2, 2, 2, 2, 2, 3, 2, 3, 1, 2, 3, 2, 233. And I believe I missed one there, 221 I missed. So add up the sums, 4, 5, 6, 6, 7, 6, 7, 8, and 5. And then very similarly, we have another 9 possibilities with 3 as the first ball being selected. Like that. 3, 3, 2, and finally 3, 3, 3. And we can, of course, create a table with these sums. 6, 7, 8, 7, 8, 9. So they're asking, what is the probability that the sum of the 3 recorded numbers is less than 8? Well, the total is 27. Now, how many are less than 8? Well, very quickly we can figure out how many are 8 or greater. This one is 8 or greater, this one is 8 or greater, and this one and this one. So there's only 4 that are 8 or greater as the sum, 4 possibilities. So that means the remaining are all less than 8. So that would be 23 that are less than 8. So the answer to this question is 23 over 27, which is choice A. A beam of light shines from point S, reflects off a reflector at point P, and reaches T so that PT is perpendicular to RS. Then X is. Well, the first thing I'd like to do is draw a diagram. Now, the key to this question is to drop a perpendicular from P to RS. So like this. Like that. And therefore this becomes 90, and we can then work with this question. So this, they've told you, is X. They've told you that this is X, and this is 26. Now, this angle in here is also going to be X. Why? Because it's directly opposite that one. And vertically opposite angles are the same. And as you can see, those two are indeed vertically opposite angles. So in this triangle here, we know that the sum of the angles are always going to be 180. So we've got 90 as this right angle. We've got 2 x's, and we've got a 26 in there. So that means if you do the algebra here, 2x is equal to 64, and therefore x is equal to 32. So the answer here is B.